Point 4 is going to be writing the equations of a line. Let's see. Get some paper under there. There we go, that's better. All right, when we write an equation of our line, our final form is slope-intercept, y equals mx plus b. That is going to be the goal, to get it into slope-intercept form. And when you're writing an equation, you can be given different pieces of information. Some of it obvious, and some of it where you're going to have to do a little bit of work. So we're going to start with the most obvious one. Given an m and b. Well, if you're given m and b, and the only thing that's missing in a slope-intercept form is m and b, because y and x are still variables, then all we do is substitute it in. So here's a couple of examples. Slope is 2/3. Y-intercept, b is -4. So y equals mx plus b is my goal. If I know what m is, plug it in. And if I know what b is, plug it in. And when we write an equation, this is how we want to make fractions, up and down, not sideways. And the reason for that is because 2/3 x is not the same as this one. This has x in the denominator with the 3. This has x as a variable of the coefficient 2/3. So we do not write fractions sideways. We write them top and bottom. All right, on the next one here, the slope is -1. So there's my slope. And my intercept is 0. Now anytime we have 1s and 0s, we need to clean it up. We never write 1s as coefficients, so that's just -x, and we never write +0 on the end. So we would rewrite this as y equals -x. So given m and b is the simplest version, just substitute in m, substitute in b, there's no work required, and you're good to go. In the next one, you're going to be given a point and a slope. When you are given a point and a slope, we're going to be using the point-slope formula. So given the point and a slope, we're going to use the point-slope formula and solve for y. All right, well, the point-slope formula, we've used it in the past, but in case we don't quite remember what that is, let's take a look. It is y minus y1, mx minus x1, where y1 and x1 is the given point, and m is the given slope. Hence, point-slope formula. So on this example that we're going to look at, if I gave you -3, 4, and a slope of 2/3, given a point, given a slope, so we want to plug in the information. Y and x are variables. Y1, x1 are the points. So it's y minus y is m, x minus x. We should know that two negatives make a positive. So that's where the x plus 3 comes in. First of all, we're going to distribute by order of operations. 2/3 x, and then 2/3 times 3, well, the 3's cancel, so that's plus 2. Add over the 4, so y equals 2/3 x plus 6. And there's your equation. Slope-intercept form and all. Plug in the points, plug in the slope, solve for y. So that means follow your order of operations. Distribute, combine like terms. In this case means gets the constant over to the other side, and you have no coefficient of y, so you're good as y equals mx plus b. Second example, if I tell you slope is -1 and the y-intercept is 0. Oh, I'm sorry, that was last example. How about if the point is 2, 1 and the slope is undefined? That's better. All right, so an undefined slope, little bells and whistles should be going off. Ding, 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 ding. Something's not right. This is special. This is unique. And when that happens, I don't necessarily follow my point slope formula. When I see something is special, and that means the slope is undefined or the slope is 0, or I see a picture and it's vertical and it's horizontal, or I see an equation and there's only one letter, little bells and whistles need to start going off. An undefined means it's a vertical line. It also means x equals a number. Well, if this is my point 2, 1, x is 2. You're done. That's it. That's all there is to it. When you have specials, you only have one letter, you only have one number, and if you know what that point is, you just match up its position. X is the first position, so x must be 2. All right, moving on. So that's given a point and a slope. Let's look at given 2 points. If you're given 2 points, you need to find slope, because that's what's missing from your point slope formula. And then you're going to use one of the points in the point slope formula. But in order to use the point slope formula, you have to know slope. So that's the first thing that we are going to do. All right, here's 2 points. 1, 5, and 4, 2. To find the slope, we use our slope formula, which is y minus y over x minus x. So we get 3 over -3, which gives me a -1. Now I'm going to use one of the points. It does not matter whether I choose 1, 5 or 4, 2. I'm going to get the exact same results. I'm just going to pick the first one just because it's first. No special reason. So I'm going to go y minus y, m, x minus x. There's the point slope formula. So the first thing I did was find the slope. Got that. And then it says I'm going to use one of the points, doesn't matter which one you choose, in the point slope formula. Solve for y. So y minus 5 is -x plus 1, because when I distribute, so y is -x added over plus 6. There's your equation, slope-intercept form. First finding the slope, then using that slope and one of the points in the point slope formula. So let's try that again. Let's look at the points 3, -1, and then -1, -1. First thing I do is I find my slope. The slope is y minus y over x minus x. Two negatives make a positive. -1 plus 1, 3 plus 1, 0 over 4 is 0. Ding, 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 bells and whistles. Anytime we see a slope of 0 or undefined, that is special. A special is only one letter. A 0 slope is horizontal, which means it is y equals. And look up at those 2 points. Look at those 2 y's. They are the same. That's what y equals, -1. Now, if you recognize those points are the same from the get-go, you can just jump down to y equals -1. But if not, find the slope, and once you come up with that special 0 or undefined, ding, 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 bells go off, you jump straight to y equals or x equals based on is it a 0 slope or an undefined slope. All right, so we have given an m and a b, given a point and a slope, given a point, and given 2 points. Now we have to write equations of lines if we only know parallel and perpendicular. All right, write an equation of a line that is parallel and perpendicular to a given equation through another point. Use the point-slope formula. So here's our first example. Write the parallel and perpendicular equation to this equation. See, given an equation, through the point to -3. Write equation of the lines that are parallel and perpendicular. But this time you're going to be given an equation and a point. We will be using the point-slope formula to do this. All right, so here we have our example. The equation given is y equals 2x minus 3, and the point is 2, -3. Excuse me. Let's first of all look at what is that. Y equals 2x minus 3, and there's our point 2, -3. The equation, 1, 2, 3, -3, 1, 2, 1, 1, 2, 1, looks something like this. This is our original equation. And we're going to go through the point 2, -3 here. Now we want the equation that is parallel to my original, and we want the equation that is perpendicular to the original. So pictorially, that's what it looks like. And remember the other day when I said you need to understand things in multiple ways. It's not enough to just read the words or to just look at the equations, but to also understand what's happening pictorially. We want these green lines. We want the equation of the parallel line and perpendicular line to this original equation such that the parallel and the perpendicular goes through this point. Okay? So in order to use the point-slope formula, though, we have to know a point and we have to know a slope. Well, the point is given to us. This is the point that is on the parallel line, and it is on the perpendicular line, so we don't have to worry about it. The slope, well, that's what we got a couple days ago. If I know an equation is parallel to something else, I should know their slopes are the same. Therefore, the slope is 2, because we can go right up here and look. Y equals mx plus b. 2 is in the same location as m. Therefore, the parallel slope is 2. The perpendicular slope is opposite and reciprocal. Well, that means opposite is negative and reciprocal 2 is 1/2. So my two situations are parallel, which is a point of 2, -3, and a slope of 2. Y minus y is mx minus x. Distribute. Combine. There's the parallel line. This is the parallel equation, this line, to my original. And it goes through this point. Perpendicular. Same point. We already know the slope, opposite and reciprocal. So it's a matter of using the point-slope formula. Y minus y is m x minus x. Distribute, so y plus 3 is -1/2 x plus 1, because half of 2 is 1, 2 negatives. So y equals -1/2 x minus 2. There's your perpendicular equation. This perpendicular equation is this line pictorially. Now, do you have to create this picture? No, you don't. But you better be able to understand it pictorially. You need to be able to understand things graphically, numerically, algebraically, and within words. That whole gnaw process. You need to know what it looks like to be parallel perpendicular. What equations look like. What does the numbers look like? What does it look like in words? So let's try that one more time. Find the equation that's parallel and perpendicular to y equals -x plus 4 through the point 4, -1. So take a minute, pause the video. Yes, actually hit pause right now. All right. So here we're going to have the point for -1, and the parallel slope is the same at -1. Y minus y, mx minus x, distribute, and combine. To do the perpendicular slope is +1. Y minus y, mx minus x. Y plus 1 is x minus 4. So y is x minus 5. That is what you should have got when you paused the video and tried it on your own to get the parallel and perpendicular equations. Alright, so that's how we're going to write equations. We're going to write equations from given an m and b, given a point and a slope, given 2 points, and then given an equation, and through another point we're going to write parallel and perpendicular. And we will look at examples of this, or problems of this we will practice tomorrow in class.